Hey guys, so for number 40, we're going to graph the rational function. So there are a couple different steps we're going to follow in order to completely graph the rational function. So let's go ahead and get started. First, we're going to find vertical asymptotes if there are any. So we're going to look for our restricted values. In this case, we have a rational function, so our denominator can't equal 0. So when we solve for x, we get x can't be 3 and negative 3. So that tells us that on the graph that we have, wherever the x equals negative 3 and 3, we have vertical asymptotes represented by dashed lines. Next, we're going to look for horizontal asymptotes, if there are any. And horizontal asymptotes have to do with the degree in the numerator versus the degree in the denominator. So the degree in the numerator is 0 and the degree in the denominator is 2. So the degree in the denominator is bigger. So that means we have a horizontal asymptote at y equals 0. If you need a refresher on horizontal asymptotes, if you take a look at video number 36, for question 36, there is a detailed explanation on horizontal asymptotes in that video. Next, we're going to be taking a look at our intercepts. In order to find the x-intercept, we're going to set our y equal to 0. So that's going to be f of x as 0 is equal to negative 2 over x squared minus 9. And when we solve for x in this case, we have to multiply both sides by the denominator of the right-hand side. And in doing so, that will give us 0 is equal to negative 2, which doesn't make sense, so we have no x-intercept. Now let's take a look at our y-intercept, and that is when we set our x equal to 0. So that is going to give us f of 0 is equal to negative 2 over 0 squared minus 9. And when we try to simplify that, we get f of 0 is equal to negative 2 over negative 9, which can be canceled out, leaving us with just 2 over 9. So our y-intercept is 0, 2 over 9. Lastly, we are going to be taking a look at some test points on this graph to complete what this graph is going to look like, and finally try and connect our dots, or connect them as best as we can, not crossing any asymptotes. So let's take a look at the furthest left side over here, and let's use the test point negative 4, where x equals negative 4. What happens when x equals negative 4? Now we already have a point between negative 3 and 3, which happens to be our y-intercept. So then let's go ahead and use the test point x equals positive 4, which is going to be our point furthest on the right over here. So when we plug in x equals negative 4 into our equation, we get negative 2 over negative 4 squared minus 9, which equals negative 2 over 16 minus 9, which equals negative 2 over 7. That means that at negative 4, our y value is going to be negative, so it's going to be in this region right over here. So from there, we can tell that our function is going to cross over here, and it can't go past the horizontal asymptote, so it's going to extend this way forever. Now in the middle, we already have a point on top of the horizontal asymptote, so we know that it can't go back down. And also we have a vertical asymptote at negative 3 and a vertical asymptote at positive 3. So there's no other place for this function to go except along those boundaries. And then for our function at x equals 4, when we plug in x equals 4, we get negative 2 over 4 squared minus 9, which equals negative 2 over 16 minus 9, which is 7, which means that when x equals 4, our y value is negative, so it's going to be within this region over here. And that is our completed graph.